In this video, we'll work through every question from the Junior Olympiad from 2023. That's one of the follow-on rounds to the Junior Maths Challenge, aimed at students aged 11 to 13. You can also practice all of these questions and more in a free course at the Mathsaurus website that I'll link below. That course also has hints to help you get started with each question, and there are no ads or distractions like there are here on YouTube. But if you'd rather stay here, you are of course very welcome to. I'll read out the question before each solution, so you can pause the video and have a go at each question before watching the solution. So let's get started now. What is the integer nearest to 59 over 13? There are a few ways you could do this. We could just notice that 13 times 4 is 52, and 13 times 5 is 65, and 59 is closer to 65 than it is to 52, so the answer here would be 5. Another way of saying this is that 59 over 13 is 4 and 7/13, and again 7/13 is just a bit bigger than a half, so this would round to 5, or you could even just do the long division here, 59 divided by 13, and maybe you want to write out the 13 times tables quickly to do this up to a point that you need, so I would get 4 here with 7 left over, and then I would have 5 with 5 left over, and then 3 here, and we can see again this rounds up to 5. Either way, the answer here is 5. What is the solution of this equation? There are different ways you could sort out the algebra here, but this is one way. I could write 24 divided by 3 over 2, because 3 divided by 2 is just the same as the fraction 3 over 2, and then I could also do 24 divided by 3 is 24 over 3, and I know I want that divided by m, so that's the same as 24 times 2/3, and I've got 24 divided by 3m. Dividing by m just puts the 3 on the bottom of the fraction. You'll notice I didn't cancel 24 divided by 3 as 8, although you could do, but I could actually now just divide both sides by 24, you see, because I haven't done that, and I can cancel out these 24s, and then I can also cancel out the 3's here, multiplying both sides of the equation by 3, and I'm just left with 2 equals 1 divided by m, and then either taking the reciprocal of both sides or multiplying by m and dividing by 2, we get that m is equal to 1/2 for the answer there. But as I say, lots of ways you can do the simplifying and the cancelling and things if you want to there. Two triangles are drawn so that they overlap as shown. What's the sum of the marked angles? Well, let's call this one A, this one B, this one C, and this one D, these sort of interior angles, because the A, B, C, and D are the interior angles of a quadrilateral. We know that A plus B plus C plus D is equal to 360 degrees. So this angle out here is 180 minus A, this one's 180 minus B, this one's 180 minus C, and this one here is 180 minus D. So the angles that we want are actually two copies of each of these. We want two lots of 180 minus A plus 180 minus B plus 180 minus C plus 180 minus D. And that means that we're going to have two lots of 720 minus A plus B plus C plus D is what we want, and A plus B plus C plus D is 360, so that's two lots of 720 minus 360, that's two lots of 360, and so the total here is 720 degrees. Actually, perhaps an even easier way of seeing this is if you consider this quadrilateral on the inside. We could say actually here's one exterior angle, and I go around and I get to the next exterior angle here, and I go around and get to the next one here, and I go around to the next one here. The exterior angles of a polygon sum to 360 degrees, so you could also just say straight away that it's 360 times 2, which is 720, if you have that insight. But these short answer questions, doesn't matter how you do the working, so however you get there, worth 1 mark either way. What is the value of this expression? Give your answer in its simplest form. Very often in maths challenges and Olympiads you have to try to decide whether it's worth looking for fancy tricks or just to get on with a more brute force way of just doing the calculation. And here, when all the numbers are quite small, you know it's not going to take long to work this out, so I would just get on with the calculation here. 1 squared plus 1 is 2, 2 squared plus 1 is 5, 3 squared plus 1 is 10, and then I've got divided by 2 squared minus 1, which is 3, 3 squared minus 1 is 8, and 4 squared minus 1 is 15. And we're going to just look and see if anything cancels here. So I can cancel a 2 with the 8 here, I can get rid of a factor of 5 here, top and bottom, and Actually, I can get rid of another 2 from here, and this 4, so I've got just here 5 over 3 times 2 times 3, so that's 5 over 18, and that's the final answer there. Doesn't take too long. A number line starts at minus 55 and ends at 55. If we start at minus 55, what percentage of the way along is the number 5.5? Well, to get to 5.5 from minus 55, we're going to have to go past 0 here, so the distance from minus 55 to 5.5 is 55 plus 5.5, and the total distance from minus 55 to 55 is 55 plus 55, or 110. You could write the top as 60.5 and then simplify the fraction, perhaps times top and bottom by 10, or you could just notice here that there is a factor of 11 sort of top and bottom here, right? So I've got 11 times 5 plus 0.5 on the top, and on the bottom I've got, of course, 11 times 10, because 11 times 5 is 55 and 11 times 0.5 is 5.5. So that would give me, cancelling the 11s then, 5.5 over 10, which is 55 over 100. So it's 55 100ths of the way along, which of course corresponds to an answer here then of 55% of the way along. Lots of 5s in this question, A5. Bit of a classic type of question, this one, number 6. A tea and a cake costs £4.50. Tea and an eclair costs £4. A cake and an eclair costs £6.50. What's the cost of a tea, a cake, and an eclair? And this is really a question that's about using symmetry in algebra. So let's call the tea x, a cake y, and the eclair z. So what we've got is x plus y equals 450 if I just work in pence to avoid having decimals flying around. And then I've got tea and an eclair, that's x plus z, is 400 pence. A cake and an eclair then, that's y plus z, and y plus z is 650. And the trick with these sort of symmetric algebra problems is to add everything together. So on the left hand side I've got 2x plus 2y plus 2z, because you know there are 2x's here, 2y's here, and 2z's here. So when I add all of those together I get the same as 450 plus 400 plus 650, and if you add those together carefully you get 1500. But of course now I can divide this whole equation by 2 and get x plus y plus z equals 750 pence, and so the answer to this question is that they cost £7.50, and that's the answer. A 2 by 2 by 2 cube has a 1 by 1 by 1 cube removed from it to form the shape as shown. One of these shapes is inverted and put together with a second shape on a flat surface as shown. What is the surface area of the new shape? These can be quite hard to visualize, so what I've done here is I've just stuck some of my dice together and made 2 of these shapes for you that you can see here. And if I put them together, what you can see is that if I was to put them on a flat surface here, on the bottom we would see 7 1 by 1 squares, and that would be the same on the other side as well, 7 1 by 1 squares. And as I go around the other 4 sides we can see each side has a 4 and a 2 to make 6, a 4 and a 2 to make 6 here, a 4 and a 2 to make 6 here, and a 4 and a 2 to make 6 here. So overall what we've got is that there are 2 times 7 plus 4 times 6 of these individual 1 by 1 centimetre squares that make up the surface area of the resulting shape. So that's 14 plus 24, which is 38, each of them 1 centimetre squared, so that gives me 38 centimetres squared for the answer there. Alex chooses 3 from the 6 primes in this list. The mean of his 3 primes is 2023. What is the mean of the other 3 primes? They always like to get the current year in the paper somewhere if they can. The trick to this one really is not to worry too much about which primes they are and just think about them in total. Right, so if the mean of 3 numbers is 2023, the total or the sum of those is 3 times 2023, which is 6069. Next, if we were to add together all 6 of the primes here, the sum of these 6 you can check is 12,126. So you need to be able to do a bit of fast arithmetic in this question. So the remaining primes must total 12,126 minus 6,069, and again a little bit of quick arithmetic here will get you to 6,057. Either you may probably be able to do this in your head if you think about it, or you can just do column subtraction, whatever your favorite method is here. So I've got 3 remaining primes that sum to 6057. So that means that their average or their mean here is going to be 6057 divided by 3. So you can just do a quick long division there and get that that is 2019. And so the answer to this question is 2019. This is a very nice question. The diagram shows a square PQRS. Well, you can imagine that the square is underneath here, and that has area 25 centimeters squared, and a rhombus QRTU here, which has area 20 centimeters squared. What's the area of the shaded region here, this part? Well, we start with the square, which is 25 centimeters squared, so we know that that square is 5 centimeters by 5 centimeters. Now for the rhombus, we need to think a little bit more. If you don't know the formula for the area of a rhombus, I'll forgive you. You can split it into 2 here, and you could say that we've got 2 congruent triangles here, like one here and one here, and they are each equal to a half times the base times the height. Right, each of the individual triangles is a half times the base times the height. So the rhombus overall would be 2 lots of this, which is just the base times that perpendicular height. So you see, if the area of the rhombus is 20, then 5 times the height has to be 20, so that perpendicular height there has to be 4 centimeters. Now, that means that I know that this part here is 1 centimeter, so this is 1 centimeter by 5 centimeters, and this area of this top rectangle is 5 centimeters squared. So if I can work out the area of this triangle, then we're done. Now, of course, we've got 4 centimeter height here, and so this is also 4 centimeters here, and because this rhombus, the definition of a rhombus is that all of its sides are the same length here, then this side length is also 5 centimeters. So I've actually got a little Pythagorean triangle here. So, you know, if I just make this clear, there's 5, 4, and so this is the famous 3, 4, 5 triangle. Or if you want to, you apply Pythagoras theorem and say that's x, and you've got x squared plus 4 squared equals 5 squared, right? So x squared equals 25 minus 16, which is 9, and so x equals 3 here, because x has to be positive, of course, can't be minus 3. So this is 3 centimeters, and so this triangle here is the area is a half times the base times the height, so a half times 3 times 4, so that's a half times 12, which is 6 centimeters squared, and so the total shaded area then is this bit, which is 6, and this bit, which is 5, so 5 plus 6 equals 11 centimeters squared, and that's the answer there. Well done if you got that. What is the remainder when 2, 3, 2, 3, 2, 3, etc. repeated 23 times is divided by 32? Very tough question. And I would say strategically, it doesn't make sense to spend too much time on these last questions in the first section. Do have a go at them, but all of section A are just worth 1 mark each, and then the section B questions are worth 10 marks each. So don't spend ages on questions A, 9 and 10 if you get stuck on them. Do go on to section B and come back to these if you've got a bit of time towards the end perhaps. This is a really interesting question though, and it's worth paying attention to because you can learn a lot from it. And if you know your divisibility tests really well, you'll know there are divisibility tests for 4 and for 8 that we talk about quite often, which say that the last 2 digits have to end in a multiple of 4 for the divisibility by 4 test, or a multiple of 8 for the last 3 digits have to end in a multiple of 8 for the divisibility by 8 test, right? And the reason they work is that we've got 10 equals 2 times 5, and we've got 100 equals 2 squared times 5 squared, you know, that's 4 times 25. 1,000 would be 2 cubed times 5 cubed, that's 8 times 125. So you see, anything that's a multiple of 100 is a multiple of 4, and then I only have to look at the last 2 digits to determine whether the number's a multiple of 4, because if that's a multiple of 4, I'm adding together a multiple of 100 and a multiple of 4. I've got another video on divisibility tests on YouTube and in the free preview section of the Go for Gold in Maths Challenges course if you want to dive into a bit more detail on that. But that's why they work. And you see, the nice thing about that is then I can actually get divisibility tests for higher powers of 2 as well quite easily, right? Because 10,000 is 2 to the 4 times 5 to the 4. So if I want a divisibility test for 10,000, I can just check, for a divisibility test for 16, I can just check the last 4 digits, because anything that's a multiple of 10,000 will be a multiple of 16. And for 100,000, that's 2 to the 5 times 5 to the 5, right? And again, 2 to the 5 here is 32. So anything that's a multiple of 100,000 will be a multiple of 32. So I only need to look at the last 5 digits of this number and to see what the remainder is when that is divided by 32, and it will be the same as for the whole number because the rest of it is just adding on a multiple of 32. So we just do a quick long division here, and the last 5 digits, thankfully, are 3232, 3. So actually it's quite an easy long division to do, right? 32 goes once, and then I get a 0, and then a 1, and then a 0, and I've got left over this 3 on the end. And so the answer here is that the remainder is 3. So very well done if you got that right. Here's question B1, and in section B of the Junior Olympiad, the questions are worth 10 marks each, and the marks are awarded not just for your answers, but also for the quality of your written explanations. So it's important to set out very clear working for these. Don't think that means you have to write a huge amount necessarily. For some of the earlier questions in particular, and sometimes even for the later questions, a very short answer or a quite short answer can be enough. Just a few lines can get you 10 marks if it's clearly explained. In fact, on the whole, shorter answers are better so long as they're clearly explained. So some of the answers will require much longer written answers, but not necessarily. So we'll bear that in mind as we do this question. It says the sum of the 4 fractions is less than 1. 3 of the fractions are a half, a third, and a tenth. The 4th fraction is 1 over n, where n is a positive integer. What values could n take? Well, if I add together the sum of the 3 fractions that we start with here, 1/2 plus 1/3 plus 1/10, we can put them over a common denominator of 30. That's 15/30 plus 10/30 plus 3/30. Adding those together then gives 28/30, which is 14/15. So for the 4 fractions combined to not be bigger than 1, we could just say, this leaves at most 1 minus 14/15, which is 1/15 for the 4th fraction. And so what we have essentially said there is that we need that this 4th fraction, 1 over n, to be less than 1/15, and that is to say that n has to be bigger than 15, or if you like, you could say n is greater than or equal to 16. So in fact, n can be any positive integer then, which is greater than or equal to 16, or perhaps it's more efficient just to say can be any positive integer greater than 15. So that's enough to answer this question and to get full marks, but you do have to be precise. People are often surprised when they lose marks in these section A questions. They might have said greater than or equal to when they meant greater than. They might have missed out a few words. They might not have come to the right conclusion. So I would always, if possible, just have a quick conclusion statement at the end, just to show that you've come to the end of the answer and you've really answered it, and that all of your working has built up to that. But that doesn't mean you need to write an essay here. Something of this length is perfectly suitable for a question of this type, as long as it's clear and concise. Laura went for a training ride on her bike. She covered the first 10% of the total distance in 20% of the total time of the ride. What was the ratio of her average speed over the first 10% of the distance to her average speed over the remaining 90% of the distance? When you have questions where you're going to use a little bit of algebra, it's very important that you introduce what the terms are in your algebra are to make it a full written solution. This is again somewhere where people lose marks where they don't expect to necessarily, even if you think you've used a very obvious letter to label what you're looking for, right? So in this one, I'm going to say let the total distance be d. If you wanted to, you could use a different letter, or you could also use 10d, would actually be quite a sensible choice for this question, as we'll see. But I'm going to just say let the total distance here be d, and the total time be t. Perhaps I wanted to be really thorough, I might say the total time for the whole journey or for both parts of the journey combined. Now we've got speed equals distance over time, of course, as the formula that we're going to use here. Perhaps I should say average speed equals distance over time. And so for the first part of the journey, the average speed is going to be the distance for that first part of the journey, which is going to be 10% of the total, so that's 0.1d, divided by 20% of the time, which is 0.2t. Now again, you see, this is where I could have said 10d and 10t instead of d and t, and then I'd have just had a d over 2t here. But it doesn't matter, right? Because I can now just multiply top and bottom of this fraction by 10, and I get d over 2t for the average speed for the first part of the journey. Then for the second part of the journey, right, we've also got then the average speed is the distance for that part of the journey divided by the time for that part of the journey. So the distance for that second part of the journey will be the remaining distance. So if it was 10% for the first part, it's 90% for the last part, so that's 0.9d, and the time remaining for the second part of the journey will be the 80% left, so that will be 0.8t. So that's going to give me 9d over 8t, again multiplying top and bottom by 10 here. So that means that the ratio that we're looking for is d over 2t on one side of the ratio to 9d over 8t on the other side of the ratio. So you can divide both sides of the ratio by d and multiply both sides of the ratio by t, so the d's and the t's cancel here, right? So I'm just left with a ratio of 1/2 to 9/8. Now I'm not sure if you would get full marks for leaving fractions in your ratio here. I would like you to simplify it to tidy it up here, I think. Multiply both sides of the ratio by 8, and then we'll get a ratio of 4 to 9 there as a nice simplified final answer. This question B3. As Rachel travelled to school, she noticed that at each stop, one passenger got off of the bus and X passengers got on, where X is greater than or equal to 2. After 5 stops, the number of passengers on the bus was X times the number of passengers before the first stop. How many passengers were on the bus before the first stop? Again, because this is clearly an algebra question, I'm going to set up whatever algebra I use. I don't need to re-explain the X that's already used in the question though. But I am going to introduce another letter, and I'm going to call it N for the answer to the question essentially. So I'm going to say let N be the number of passengers on the bus before the first stop. Okay, and really important that we do write this as part of our answer to make sure we get full marks and to make sure that our answer is really clear and our algebra is set out. So then we can say that after 5 stops, because we've got one passenger getting off and X passengers getting on at each stop, there will be n minus 5 for the 5 that have got off, 1 at each stop, and then there'll be 5x passengers that have joined. So overall we'll have n minus 5 plus 5x passengers on the bus. Now, so after 5 stops, the number of passengers on the bus was x times the number of passengers before the first stop. So what we know then is that n minus 5 plus 5x, that's equal to x times the number of passengers before the first stop. So that's x times n, or n times x. So if I subtract n from each side here, that gives me minus 5 plus 5x equals nx minus n, and we can factorize each side here and say that this is 5 times minus 1 plus x, or let me write x minus 1, just writing 5x minus 5 instead effectively. So 5 times x minus 1 is equal to n times x minus 1. And this really does tell me then that n equals 5, but because I've divided both sides by x minus 1, we need to just make sure that the things we're dividing by are not 0, right? So technically, actually, this is n equals 5 or x equals 1, right? Or x minus 1 equals 0. But we're told that x is greater than 2. So that means we can rule out that case effectively. So we really do just get n equals 5, and then we can say that sort of in conclusion there were 5 passengers before the first stop. And that would be plenty for a full answer here, although I'm gradually running out of space here. 5 passengers before the first stop, and that will get you a nice full 10 marks there, I think. Here's question B4. The regular nonagon ABCDEFGHI shares 2 of its vertices with the regular hexagon AJKLMI. Show the points H, M and D lie on the same straight line. Well, we'll talk strategy to begin with, right? So we want to show that H, M and D lie on the same straight line. Now I can draw a straight line through them, and it looks like that is true. That is, of course, not the sort of argument we're going to make in the Olympiad. What options do we have? Well, we could, for example, look at this angle here and this angle here and show they add up to give 180 degrees. That would do it. What we're actually going to do is make 2 different arguments, and we're going to look at this angle HMI to begin with, and we'll work out what that is, and then we will work out what the angle DHI is by a different method, and we'll show that they are the same. So that means that if I go from I to H, I've been turning in exactly the same direction to get to M as I would be to get to D, and that would show that H, M and D are in a straight line. We'll start by working out this angle MHI then, and to begin with I want to notice that the interior angles of a regular hexagon they are all 180 minus 360 over 6, which is 120 degrees. You can use your interior angle formula directly if you want to, but I prefer to think about the exterior angle being 360 over 6, which is 60 degrees, and then 180 minus that gives me 120 degrees, so that would be the interior angle here of the hexagon. And same for the nonagon, same formula but with a 9 in place of the 6, so this angle will be 140 degrees. And what that means then is the angle HIM here is 140 minus 120, which is 20 degrees, but it's the difference between that interior angle of the nonagon and the interior angle of the hexagon here. Since the hexagon and the nonagon are regular and they share this common edge IA, that means that this length HI and this one IM are equal, and so this triangle HIM is an isosceles triangle. That means the angle MHI then is 180 minus 20 divided by 2. I take off the 20 degree angle I know here and divide it by 2, and that gives me 160 over 2, which is 80 degrees, right? So to be really clear here, the argument that we're making is that this angle is 120, this angle is 140, so that means that this angle inside here is 20 degrees, because this is an isosceles triangle, because we've got all of these common edges everywhere. Then these 2 angles at the bottom of that isosceles triangle are both 80 degrees, 180 minus 20 divided by 2 there. So we've got one of the angles that we were looking for. So next we're going to work out this angle DHI and show that it's equal to 80 degrees as well, and then we'll be done. So we're going to start by noticing that triangle DHI is isosceles by symmetry of the nonagon, right? Because, you know, we've got A, B and C on this side, G, F and E on this side, so we've got perfect symmetry here, and we can really say that DH and DI must be equal then. So, well, the hexagon HDCBAI here also has symmetry, and we can see that the angle DHI, the one we're looking for, is the same as this angle up here, HDC, but the 4 other interior angles here, the ones at C, B, A and I, are all just the interior angles of the nonagon, so they'll be 140 degrees each. So if we let the angle that we're looking for here, DHI, be equal to x, then we would have 2 lots of x, right, the DHI we have here, and the HDC that we've said is equal to it, plus the 4 interior angles of 140 degrees. That must be equal to the sum of the interior angles of the hexagon, which by the formula 180 times m minus 2 is 180 times 6 minus 2, or 180 times 4, which is 720 degrees. 4 times 140 is 560, so we've got 2x plus 560 is 720. Subtracting 560 from each side gives 2x equals 160, and dividing each side by 2 gives x equals 80, and so that means that this angle that we are looking for, DHI, really is 80 degrees. But we're not going to leave anything to chance in an Olympiad answer. Make sure you come to a conclusion at the end here. Don't just assume that the person marking it will know that the argument is over there. They may well know that, well in fact they will certainly know that because they will have thought deeply about this question, but they want to know that you are absolutely confident that you have completed the argument at this point. So we need to put one final line in, something to the effect saying, so we have shown angle MHI equals angle DHI equals 80 degrees, and hence HMD is a straight line, and then we're done. The 11-digit number A123456789B is divisible by exactly 8 of the numbers from 1 to 9. Find the values of A and B, explaining why they must have these values. A real test of all of your divisibility test knowledge here, but also a really good example of a question where you're definitely going to play around with this a little bit before you start trying to write up a final answer. In fact, there's a good idea for most Olympiad questions that you just try to get the idea of the question, and then you come back. Once you know the route through the question, you'll write a slightly slicker answer. You don't need to write absolutely perfect answers. They understand that you might go a slightly less efficient route, and you can still get full marks for not the most efficient route. But it can sometimes just save you time in a question like this, because you don't have to write out quite so much if you can find the faster route. So we look at this and we say, well, is it going to be divisible by 1? Yes, of course, it's always going to be divisible by 1. And then, if you think about divisibility by 2, 4, and 8, right, if it's divisible by 8, it must also be divisible by 2 and 4. So given that it's only not divisible by one of these numbers, 8 is a possibility, but it must be divisible by 2 and by 4. And similarly for 3 and 9, if it's divisible by 9, then it's divisible by 3. So because it has to be divisible by at least one of these, it must be divisible by 3 for sure. So we've got some ways into this question because we've got divisibility tests for 2, 4, and 3. So obviously 2 just means it ends in an even number. The divisibility test for 4 is a bit stronger, right? Which says that the last 2 digits here, 9b, has to be a multiple of 4. Well, the only multiples of 4 in the 90s are 92 and 96, and that means that b is either 2 or 6. Right, so at this point you see what you can notice. Now you might have played around with the divisibility test for 3 instead, that's fine. But once you try this divisibility test by 4, you see that the number has to end in a 2 or a 6, so it can't be a multiple of 5, right? Because the number would have to end in a 0 or a 5 to be a multiple of 5. So at this point we actually know that it's divisible by all of the other values. And in particular, the divisibility test for 9 comes into play, and if you take the digit sum of all of these, then we know that that must be a multiple of 9 because the number is going to be a multiple of 9. So we've got a plus b, and the sum of the numbers from 1 to 9, handy one to know, is 45 here, or you can just work it out quickly if you don't. So this has to be a multiple of 9, but 45 is already a multiple of 9, so I need that a plus b is a multiple of 9. So we're getting somewhere here, and I'm not writing this up as a proper answer at the moment still, right? So for a plus b to be a multiple of 9, right, well, I know I've either got b equals 2, in which case a must be 7, or b equals 6, and then a would be 3, are both possibilities. But you see, the other thing I also know now is that it's a multiple of 8, so the last 3 digits have to be a multiple of 8. So if b is 2, this ends in 892, and if it's 6, it ends in 896. Well, obviously 800 is a multiple of 8, and then 888 is a multiple of 8, so 892 isn't, but 896 is. So it must actually be the case then that b equals 6 and a equals 3. And if you just get the answer here, you will get some credit. You don't get nothing just for getting the answer. You've still found the correct answer to this problem. But most of the marks for this question I haven't got here because I haven't yet turned this into a fully worked solution. But by playing around with it in this way, I've now got in my head a strategy for a more efficient solution, and I can think about what order I need to say things in here, and perhaps even the things that I can leave out. So let's try to write up that solution together now. So here's the sort of argument we can give. Since any number divisible by 8 is also divisible by 4 and 2, and the number is only not divisible by one number, perhaps I should say by one number in the list, it must be divisible by 2 and 4. A number is divisible by 4 if and only if its last 2 digits are a multiple of 4, hence 9b is a multiple of 4, and so b equals 2 or 6. Notice I don't have to explain why the divisibility test works, so you're allowed to quote those, but just explain clearly what you're using and how it applies to this question, putting a number like this in inverted commas in like 9b shows that I'm referring to it as a combined number, not as the individual digits or as 9 times b or anything like that. So now, since the last digit is not 0 or 5, we know the number it is not divisible by is 5. And since it is divisible by 8, the last 3 digits, 8, 9b, give a multiple of 8. 892 is not a multiple of 8, but 896 is, and so b equals 6. Notice I'm not necessarily writing this absolutely perfectly, I'm making a very clear argument though as we go through. Finally then, since the number is a multiple of 9, its digit sum, 45 plus a plus b, which we now know is 51 plus a, because b is 6, must be a multiple of 9, hence a equals 3, and then we can conclude by saying, so we've found a equals 3 and b equals 6, just put them in the box for emphasis, but no marks for that really, and it can be checked by division that the resulting number is also a multiple of 7. Again, here at this point, I doubt they're penalising you for not mentioning the multiples of 7, but I suppose technically it could be part of an absolutely complete proof there, so feel free to do a little long division at the bottom if you want to, but I think at this point you've pretty solidly got 10 out of 10. The diagram shows 5 circles connected by 5 line segments. 3 colours are available to colour these circles. In how many different ways is it possible to colour all 5 circles so that circles which are connected by a line segment are coloured differently? The key for this sort of question is being really systematic and very, very thorough in your answer. So let's see how to solve this now. This is definitely a problem you'll want to play around with a bit before you come up with a full solution like this, but so I don't spend too long writing it out while saying it, I've written out the solution in advance here. So we're going to split this problem into cases, and splitting the problem into cases is a really nice, clear way of setting out working for this sort of problem. So the first case I'm going to consider is where the bottom left and the top right are the same colour, and I will call those then both colour B, and then I've got colour A and A here because that's my case 1A. So with these two the same, the two B's, either I could have A and A here, or I could have A and C here, and that wouldn't have any two colours next to each other. So my first case I'm going to consider where I've got those two the same and also the other two the same, and that means that there are 3 choices for my first colour A here, but once I've chosen that colour A, I've only got 2 choices for what I do for B, and then in this case I'm just guaranteeing that A is going to be the same in the bottom right here, and then the middle circle could be either colour B or C. So overall I've got 3 choices for A, then 2 for B, and then finally I've got 2 choices for the centre. So that gives me 3 times 2 times 2, which is 12 ways that correspond to case 1A there. And in case 1B, I'm still keeping the top left and the bottom right the same colour, but now I'm going to allow the 2 in the top right and the bottom left to be different colours. And again, this time I'm going to have 3 choices for A, 2 choices for B, but then C has to be fixed because that's the condition of this case, that they're different colours, but then in the centre I could still have either B or C. So there would be 3 times 2 times 2, which is 12 ways corresponding to that case as well. And finally, the other case I can have here is that the bottom left and the top right are different colours, so I've got B and C here, and then that would mean that the top left and the bottom right both have to be A. Again, I might actually, if I wanted a really thorough solution here, just add in one line there saying that means the top left and the bottom right have to be the same colour and have to be the third colour, but I think it's quite clear from my diagram as well. So here there's 3 choices for A, 2 for B, and then C is fixed again, and then there's 2 choices for the centre colour. It could be either B or C, and so that gives me 3 times 2 times 2, which is 12 ways as well, and so that means that in total there are 12 plus 12 plus 12, which is 36 different colourings possible. I have been systematic and thorough here and found all of the possible cases and given what I think is a pretty clear argument. It is very tough to give very clear answers for this sort of problem, and that's why very few students in the Olympiad get full marks. But if you're getting anywhere near close to that, you will be doing very, very well indeed. In fact, even getting 1 or 2 of these questions out is a great achievement and puts you amongst the very best students out there. So the main thing, of course, is to enjoy the problems, to have a go at them, to learn something from them, and I hope that you have done that here. So well done if you got it right. And don't forget, you can find loads more questions like this with hints and solutions over at the Mathsaurus Courses website for the Junior Kangaroo, for the Olympiad, for all of the other maths challenges from the first maths challenge right up to the senior maths challenge. Or if you want to watch more solutions like this on YouTube, check out this video on the screen right now.